Okay, so here we're kind of first of all reviewing arc length. Remember, a lot of our arc length things we did have to rely on technology, and so we want to begin this problem. We're going to see what happens. This is not a very complicated function, but let's recall first of all what arc length is. Right, it's the integral between your two endpoints of the square root of 1 plus the derivative of the function squared dx. So in our example, since our function is 3x squared, we need to first compute its derivative. That would just be simply 6x. And so the arc length would be the integral from 1 to 4 of the square root of 1 plus the derivative quantity squared dx. And simplifying, we would get to the integral 1 to 4 of the square root of 1 plus 36x squared dx. And then this is where we run into a problem. We can do some further adjusting like we did in the past, right? Factoring some stuff out, right? To get that to just a single x squared. But even then, it's not going to matter. We were able to manipulate a few things. We were able to manipulate a few things in the past, back in 8.1, right? Where we were able to even complete the square, but that was because the whole thing was fitting the format of the antiderivative of arc sine in that example, or as it was in the previous examples, right, the antiderivative of tangent, of the inverse tangent. So we were able to kind of manipulate things. But here, we had a square root of 1 minus u squared. We were able to get it that way. Here we had 1 over u squared plus 1. Well, this time now, even if I do my factoring, I take the 36 out of everything and then do the square root and get 6. Square root 1 over 36 plus x squared, right? Even then, this thing is in just a square root of 1 of something, something plus x squared. Right? It's not right. So we're kind of run into a wall. Like, how do we do this? And the key is actually going to be this idea here. It's going to let us deal with a lot of things that involve a 1 plus something squared, or 1 minus something squared, or the other way, something squared minus something else. And so we're going to learn how to do that. And the key is going to be trig substitutions. So we kind of come here, we simply ask the question right now, now what? Now what? And the solution is to use trigonometric substitutions, or simply trig substitutions. And so we use trig substitutions when working with things of the form a squared plus x squared, or u squared, either way. A squared minus x squared, or again u squared, or in the form x squared minus a squared. Okay. So we're going to look at those three scenarios. And each one of these is going to lead to a particular trig substitution. So let's look at the first one here, which is a squared minus x squared. Okay, and see how that expression can be used to involve a trig function. So let's look at that a squared minus x squared situation. So the idea is this: where does a squared minus x squared come from? Well, if we have a right triangle, we have a right triangle, and the hypotenuse is A, and the one leg is X, and our angle is theta, then of course the third side would be the square root of a squared minus x squared. Right? We're able to bring that out in a right triangle. But what do we know here? What else do we know in this picture? Well, we know from this picture, the definition of this picture, that sine of theta is A over x. Sine of theta is, I'm going to get it right eventually here. Sine of theta is the opposite x over a. Sorry, got it. Mine just stumbled there for a moment. So we also know that. So in addition to the relationship there, we know that sine of theta is equal to opposite over hypotenuse. And so that means that x is equal to a sine theta. Okay. So that means this third side of this triangle, square root of a squared minus x squared, can actually be written as the square root of a squared minus x squared, a squared sine squared, right? And we can factor out an a squared and have 1 minus sine squared. And simplify. Square root of a squared is just a. And we'd have square root of cosine squared, which would bring in absolute value of cosine. Okay, so we're going to be able to transform something like this eventually into something involving a trig function. So that's kind of going to be the idea here. If we have a squared minus x squared, we can let x replace a sine of theta. Right? And the hope is that we produce some kind of integral that we can actually work out. Okay? Some kind of integral that we can actually work out.